Okay, so we'll go ahead and take a look at what we were working on the other day. I think we worked on this one here called count 1 to 5. Right? Okay.
Left off on factoring.
You did factoring as well.
I did factoring too? Okay. So factoring was the last one. I think that was the very last one that we worked on. So factoring is here. Okay. So are there any questions about this particular program, factoring? Any question about the blocks that I use inside? Or the fact that you can have blocks inside blocks? Have we seen anything like this? You can have a block inside a block or a container inside a container?
Visual Basics, that's what.
Visual Basic has it, but I'm talking about outside of the context of programming. Go ahead. HTML, okay, HTML elements, you can have elements within elements. What about something even more common that people have to do? If you use a computer, you have encountered this concept. Yep. Yeah, folders, exactly. You can have a folder inside a folder inside a folder, right? And it's the same thing here. So in this case, you can see what we have is a loop. Okay, let's go from the innermost part. This is the innermost part because to change a potential factor by 1 cannot have any subcomponents except for the expression on the right hand side, because you can change it by a certain expression. But this loop here, this repeat until, is surrounding just the change statement itself. But these statements, from here all the way down to here, they're all inside another loop. So you can have a loop inside a loop. You can have a conditional statement inside a conditional statement, and so on. Are there any questions about the fact that you can have statements inside statements, or blocks in this case, blocks inside blocks? The questions? Okay. If there are no questions about the blocks, are there any other questions about this particular program? Let me just kind of show the program a little bit more so we can kind of focus on this, and you can tell me or ask questions right now if you have any. No questions? Yep, go ahead.
Is there a way that when you're running it, one of the scripts, it highlights it?
Mm-hmm.
Is there a setting or something that you can make it so that it highlights the actual, I guess, the line of code?
The actual line of code. Okay, that's a good question.
Because if you get stuck in like an infinite loop somewhere and you're not sure where.
That's a good question. I really do not know. Single stepping, that's it. So what you can do is to do single stepping, and single stepping is basically what you're looking for is it only performs one block at a time. Let's go ahead and do this, okay? Does everybody understand that question? Okay, the question was, if my program is not behaving correctly and is stuck in an infinite loop, all I can see is the entire script is active because there's the outline or the highlight around the entire thing. But I cannot just stop the program and figure out why it is stuck in an infinite loop, right? So here is a debugging tool. Debugging refers to the process of removing flaws from a program, from a script, a program, code, software, source code. Those are all pretty much the same thing. So let's go ahead and start this one by set single stepping. And it will ask me about turbo speed, normal speed, fast blocks, slow blocks. So we'll go ahead and just pick the normal pace, and we'll go start single stepping. Click the green flag. Oh, okay. I have to click the sprite in this case. Click the sprite, and we'll give it a pretty big number to deal with. 1137, 1139. And you can see, how it's doing this. It's showing you exactly what it's doing. So would that be helpful, or are you looking for a way to actually stop it when?
No, that's exactly what I was looking for.
Okay. So that can be helpful. Let me see if I can actually stop it. Stop single stepping, and that basically just keeps going at full speed. So that's not exactly what we want either. I don't think it has the ability to single step where it will just completely stop and you have to tell it to move on to the next step. Yeah, turbo speed means it's even going to be faster.
Well, if you have a problem, it'll stop right there, though, right? You'll see it into that loop, and it'll just hang right there.
Only if the problem is causing big issues, like division by 0, would cause a big issue because there's no way to proceed from that point. But if there's a problem with the logic of the program where it doesn't really cause a bad situation to happen, I don't think this approach will stop at all. Yep.
If I go to my computer and I go to Scratch,
Mm-hmm.
or I did already, it doesn't show all the features that you have. It
Doesn't
gives,
show all the
two
features.
Options. The number one option is that it's for free and they give you an amount of gigabytes to use it. And the other option is that I have to pay $10 in order to get more features. I don't know if I did the wrong one.
This is a pretty standard installation from the Scratch website. So, you should see pretty much the same stuff here. There are only a few options that are kind of optional.
I downloaded this version.
And it's the same, right?
Yeah.
Yeah, it should be identical to this one.
Well, maybe my computer is old. Because
No.
I didn't have problems with this computer here.
No,
in lab, but in my computer, it doesn't show all the.
If you download, Scratch within the last year, it has been the same look and feel for the last year. I mean, they really have not changed it since 2011. In fact, I really don't want to do this one because it's part of your homework assignment, but since it's only the first step, I think it's okay. If you go to Help and then click, About Scratch, it tells you that this is, released on December 2nd, 2011. So this has not been changed for more than a year, So if you just recently downloaded and installed it, it should be the same. So you might want to consider uninstalling Scratch and then reinstalling it. So that might be the best way to do it. Okay. Now the second thing that you can also do is, I want to show you an option here. You can say show motor blocks where the motion will have some extensions here. This is actually intended for other things, like with Lego blocks and some other blocks. You can actually have the computer to remotely control Lego motor blocks once you connect it to your computer. So normally you don't turn it on because most people do not have those particular features. Okay. Any other questions? Yep. A motor block gives you the ability to actually turn on a motor. So basically you have your regular PC, right? And then you attach your PC to a controller. It can be a Lego controller, it can be somebody else's controller. And then the controller controls, actual motors. So you can have Scratch to turn on a motor and turn it off a motor. Instead of...
Like turn on a fan like you have...
Not...
What do you mean?
I suppose you can attach a small blade, to the motors. Those are small motors, small DC motors. It's kind of like a Lego thing, How many people know that Lego has robotic kits and also the techniques, So they have motor blocks and controller blocks. Some can connect to Scratch. Yep, go ahead.
That's the same thing as you use. I forgot what the name of it was, but you were talking about a little box that ran inside of it, the link system that you could hook up to robots and stuff.
Right. Yep, go ahead.
Like Lego has like a
Mine's-
motor store? Is it like that?
Yeah, let me just look up directly, Scratch, motor, control, and that will definitely, Scratch controlling the GPIO, general purpose IO on the Raspberry Pi. So that's one. And then here's the actual wiki page for Scratch on motor blocks. So let's see what it has to do about this. What it has to say about this. The motor blocks were added in Scratch 1.4. In Scratch 2.0, the category is renamed Lego WeDo blocks. So that's basically what you need to look for is Lego WeDo. So Lego WeDo. So there you have it. Not inexpensive because it is actually intended for schools. So what you have are these motor blocks, and here's a controller. I'm not sure how well you can see it. Let me see if I can zoom in a little bit more. Zoom, 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 zoom. Okay, so here is the actual motor controller. You can see the USB connector. See this one here? That's a USB connector. So the USB connector connects to your regular PC, and then you have the motor blocks here. So these attach to these little controller here, and they connect to either a sensor block or a motor block. So this way you can control your, I think they have to attach to different points. You know, this has to connect to this, and then these probably connect to something else. I don't own one, so I don't know for sure. But there are ways to attach a motor controller block to your PC, and then you can attach Lego motors to the controller blocks. So this way you can have little experiments. If you have kids, you know, they can actually run experiments because they can tell, you know, when the motor has reached or something has reached a certain point by the closure of a switch, and then they can, you know, write a program to do something about it. Okay. Because when you turn on the motor blocks, it also turns on some additional sensor blocks. Let me turn it back on again, and you can see these are additional. Motor on for 1 second, motor on, motor off, motor power 100, which means it is at full power. You can also turn it down to like 50%, 0%, 1%, okay? Motor direction, this way and the opposite way, okay? This way and that way, I like it, you know, it's very confusing, right? Very vague. But when you go to sensing, it also has two additional things like slider, sensor value, and sensor button pressed. So these will give you the additional ability not only to interact with the sprite on the stage, but also to have real world control on something.
So you could control this or make the sprite do things that you're making this other thing do?
It will be separate. It will be independent. In other words, you know, you hook up something like this to your PC. So you have to spend like $129, $130 to buy a kit like this. But once you have a kit like this side connects to the PC, and then you can have two sensors connected to this block here, and as well as one motor connected to the block. Now this motor, okay, let me zoom in and see if it shows here. This motor has the same axle design that matches, you know, all the other Lego blocks. So you can make it to turn like a windmill, a wheel on a vehicle, or something, okay? And the switches can detect whether something has reached a certain point or how far it has gone. So this way you can have interaction with actual motors and sensors from your Scratch program. Is it making any sense?
So you're not actually making the sprite make the thing, you're not controlling the sprite to control this thing.
You're directly
They're
controlling
completely
this.
different.
They're completely different. You can have the sprite to kind of reflect, you know, what the motor is doing, but they are completely independent. And I think this is really cool because, you know, now you can have, you know, like experiments. You can build Lego kit, you know, stuff, and then you can have your PC to control it. Any other questions about this? No question? Okay, if anyone is interested in this, you would also be interested in Raspberry Pi, because Raspberry Pi also has its own version of Scratch. So if you look up Raspberry Pi Scratch, you know, it is its own version. It's not the same version that you install on a PC.
I got a $700 remote control helicopter, and I could run it off my laptop.
Oh, you can?
Without the remote.
Nice. You can turn it into a little UAV. Interesting. So in this case, you know, you can go to, you can get a Raspberry Pi for about $35, and then attach, you know, something. You can see this is a Scratch program. Let's see what this is about.
No, this doesn't look good.
Hmm?
This, oh.
So it knows whether it's a cow or a horse. Okay. Scratch programming adventure. There's no. I was trying to look up, something that would explain how to use Scratch on a Raspberry Pi. So it's probably somewhere here, but I cannot find it right away. So getting back to this program, are there any other questions? Yep.
So what are the kind of limits that Scratch can do?
The limits?
Yeah, the limits.
With version 1.4, you cannot have subroutines, which we don't talk about in this class. But in real-world programming, subroutines are a very important concept, and this version of Scratch does not have subroutines. It doesn't have true arrays. It has a list concept, but lists are kind of like arrays, but not exactly the same. And then the other part about Scratch is when your program gets kind of big, it's really cumbersome to go through a GUI to write programs. I mean, it really is very tedious. I would much rather write my programs using text, using a text editor. Yep.
Do you know subroutines will be introduced in the next version?
Yeah, 2.0 has it. 2.0 actually has subroutines already, along with many other advanced features. The only difference between 1.4 and 2.0 is 2.0 is web only. So whenever you want to use Scratch, you have to be connected to the internet. Whereas 1.4, as you see, is standalone. You install it, and you can run it anytime you want.
2.0 beta, or is it out?
I think it is still in final beta stage. So you can look at beta.scratch.mit.edu. And there was another hand. Can I answer a question? Yep, go ahead.
You kind of answered the question.
Okay.
I was going to say it was in beta.
Yeah, it has been in beta for a long time. The original wiki said it would be released sometime last year, and that did not realize. And we are already in April in 2013, and it's still not released yet. Yep.
Will they release it as a standalone after it's been tested?
I don't think so. I think that's the way they're moving, is to use a web-hosted type of interface.
For the virtual one.
Yeah, because they are doing the same thing with App Inventor, which is an Android programming platform, using basically the same kind of blocks. And that one is also web-hosted only. There's no local install. This is a little bit better from the perspective of the developer, because they don't have to write, one version for Windows, one version for Linux, one version for Mac OS 10. They just have one version that runs in a browser. Then you can use any browser to use it. So I can certainly understand why they're doing it this way. It's just that you will need constant internet access to use it. All right. Any other questions? No other questions? All right. Well, there's one more feature that I want to talk about before we kind of move on. When you write a program like this, okay, within 2 days, we can still look at this code and kind of figure out, what each block is about, why we're doing it this way, and so on and so forth. Imagine coming back to this program, 2 months from today. How many people will still remember how this program works? Okay, a few, okay, but I certainly won't be remembering a whole lot of the details without having to kind of look through the code and go, okay, what is the inner loop doing? In other words, what is this loop doing? Why do I have this loop here? By the way, what is this condition? Why do I want to check whether number to factor mod potential factor equals to 0? And by the way, what is mod? I cannot even remember what mod is. Well, there is a way you can document your program. In other words, you can add comments to your program to kind of remind you, okay, this block is about this, I'm doing this because of this reason, and so on and so forth. So I'll just go ahead and introduce that feature, because that is a very useful feature for everything. First of all, you can just say clean up. Clean up doesn't really do a whole lot. All it does is to rearrange all the blocks so that they are aligned nicely, and they all kind of stack up nicely. So if you have your blocks all over the place, and it's looking really messy, clean up can kind of just help tidy up the workbench area. If you right click on the workbench area, you can also add comment. Okay, now this is really useful. Add comment is really just giving you this little box here where you can just double click in the inside. It's just like a little post-it, okay, for the lack of a better word. It's just like a little post-it where you can say certain things like check whether we just found a factor of this number. Okay, so that's basically just a description of something. You can move this around just like this and put it next to the block that you're trying to describe. But it does have one additional feature. If you do something like this and you're adding additional blocks and stuff like that, that little piece of post-it doesn't float. It doesn't go with the code that you're actually documenting. So it stays at the same place when you're inserting and deleting code, which doesn't really help a lot. So what you can do is you can drag this until it is touching something. See how it's highlighting the block, the repeat until block here. So if it's touching something and then you release it, you can see this little line here. That means whenever you move that entire block, the comment will move along with it. Now that is helpful because now you can actually say, oh, okay, so if I move things around, add additional blocks before that, the comment will just move with the block and stay with the block, which is what you want to do. I can also add another comment about this line here, so I'll just add comment again. Move on and try the next number. Okay. And you can resize it, make it wider. You can do it like this, and then I can drag this until it is highlighting the one inside the loop in this case, and you can see that things are not exactly lined up because this one is over here and the other one is not. So if I right click and say clean up, it doesn't really do any better, but that's better. Ideally speaking, we want this one to be further away, but it doesn't seem to want to do it. Can't force it. Okay. But this is one way to document your program, so you can kind of write in your own words why you're doing certain things with the blocks. Yep.
What if you resize the bubble?
Resize the bubbles?
The second one.
I think in order to fix this, we have to move this one out of the way, and the second bubble is running out of room too. Is because of this block here. So there's no way to make it any narrower. It cannot get any skinnier.
Does that little triangle collapse at them? Click on the.
Yeah, it can collapse. Oh, okay. There you go. Nice one. There we go. Good job. That's good thing. One good thing about software is you usually can click something and try it out without worrying what that's going to do. Not a good thing to do when you're in a bomb squad. Let me see. Let's push that button and see what happens. But with software, that's one thing. I mean, it's a totally different thing. You can just try it out, and see if it works or does something that you wanted to do. All right, very good. Are there any other questions about Scratch?
So if you want
Yep.
to do the green block that's right there where it says potential factor equals 0, you do the same thing?
Sorry, say again?
See where it says the green block, right? Yeah, that one.
That one?
If you want to type something, you just do the same thing.
Well, let's go ahead and see if we can attach it to the statement. Mod is the remainder of a division. Okay. And we want to see if we can attach it to the green box. Nope, doesn't seem to be. Nope. So the lowest level you can attach to is an action block, but an expression cannot be tagged with a comment.
Is that because you could change the expressions whenever?
No, I think it just has to do with limitations, like why most people do not comment on an expression basis, but they comment on it per statement or block basis. So I think that's why it's.
And was that because expressions are usually when you set the expressions, you really.
An expression is a very small component,
Yeah.
for the most part. Yep.
I think it has to do with it being embedded. You can't really attach it to a child instead of a parent.
Well, it doesn't have any vertical distance. In other words, an expression is overlapping with the block, in terms of vertical distance.
Yeah.
So it's really hard to, figure out how to attach something to it without interfering with the comment for the block itself. So, I think it still makes sense that, we do not have the ability to comment on just the expression. Yep.
So that means that comments can be made for condition statement for use.
Absolutely.
For anything like
Yep,
that.
absolutely. You just drag the statement or you drag the comment and make it attached to any action block. You can see the highlighted portion. If something is already commented, you cannot attach a second comment to it. It's already already commented, so you can only extend what you have. But if something does not have a comment yet, you can attach to it. Any other questions? Well, since we're talking about programming, in order to finish the grading of your exam one, I actually had to write some code in LibreOffice Calc to do the computation to actually compute the grade based on the correct answer, the wrong answers, and your supplied answer and stuff like that. So that was kind of fun. I spent a little bit of time, like hour and a half last night doing that. Yep.
Can you do that one more time? How do you put joints?
How to attach the comment to the blocks? Sure.
No, the joints.
The joints?
Yes.
You mean this one here?
Yes, on the bottom joint quotation top one.
Why is that doubled up?
Yeah, what is that?
Because it is embedded. We have three things to join, right? Okay, the best way to look at it is, to look at it as a picture. A join can only join two things. Okay, so you can specify, the left component and you can specify the right component, but there are only two things you can include with a single join. So what happens when you have three things that you want to join? Well, you cannot do it with a single join. You have to do it with two joins, because if the top join here is using one join on one side, the one join on one side, the subjoin, so to speak, also has two components. So now you have three places to put your content. So that's why we have a join inside a join. We have something like this, all the time in arithmetics, right? Because when you compute what is x plus y times z, it's kind of the same thing, because in this case, the multiplication is the top level, and then you have the plus as a sub operation, just like that. So the join is basically doing about the same thing. When you have three things to join, you need to have two join operators. Okay. Is that making any sense?
And so the x and the plus would be the two operators, right?
The multiplication and the addition
Would
are
be the
two
two
operators,
operators, yeah.
right? But they are ordered like that.
Yeah.
So you cannot perform the multiplication, which is the top one, until your addition is done, because otherwise the multiplication doesn't know what the left-hand side is.
Okay.
And it's the same thing here. You have two joins. You have to finish the lower level join first, so the high level join know what is the left component.
And what is the right? Or what?
Well, the right component is right here, so it doesn't have to figure that one out. But the left one is a join operation itself, so it has to finish this join operation first.
Okay.
Yep, go ahead.
What are the limitations of the list feature
The list feature.
as compared to an array? You said they don't look the same.
I think there's one thing. One thing is the speed. I mean, if something is a list, getting to a certain element, takes more time than when it is considered an array. So the performance is definitely one of the factors. The concept of a list is a little bit out of the scope in this class, Now, a list, being a list, does give you certain options that is missing from an array. Like you can insert element in between, between two elements. With an array, it's really kind of a big thing to do. You have to shuffle things and move things around a lot. But with a list, it's like pretty easy. Okay. Any other questions? No other questions? Okay. So do you guys feel that you know a little bit about programming now, or do you still kind of feel that, I don't know about that?
Well,
I'll
the
give
way
you.
you're explaining it, it's like way easier than what we're doing in algorithm. Because in algorithm, they're like,
Well, the purpose
it's the same
of
thing that you're teaching us right now, but we're using words like that big.
Well, there's a good reason. I will show you the reason for that.
But what I'm saying is I understand
Mm-hmm.
more what we're doing in algorithm, how you're showing us now than.
Okay, this is the curriculum of this class. I'm only supposed to spend 6 hours on programming. And we have spent quite a bit more than 6 hours on programming alone already. I would consider this list here, the amount of hours to spend on each topic, somewhat, I wouldn't call it unrealistic, but it's not practical. In other words, yes, I can limit myself to only talk about programming for 6 hours. But what are you going to learn in 6 hours? That's the question. Okay, will you learn enough to make it useful? That really is the question. I can just spend 6 hours and use the textbook and ask you guys just to read the textbook and talk about it within 6 hours. But will that be useful in the end? That really is the question. Okay, any other questions about programming with Scratch? If there are no more questions about Scratch, I will move on and talk about something else. Because this is going to be, I think it's going to be an interesting topic. I'm trying to find my way back to it. I think it's back to topic 2. We are going back to topic 2. We want to talk about the components inside the computer. So what do you think would be the best way to talk about the components inside the computer? I'm asking that question not really expecting an answer, but I just want you guys to kind of think about it. Okay. Wikipedia. Well, it's kind of okay, but it's not very interactive. You're not really doing anything actively to learn how the inside of a computer operate, or what are the components inside the computer. So what I'll do is this, since everything is recorded, I can actually go back in time and document what I talked about today. I would go to some place like newegg.com, or there are other similar websites, and let's pretend that we are building a computer. Now, why would anyone try to build, his or her own computer these days? Yep.
Way cheaper.
It's cheaper for high-performance computers, yes. Okay. If you want something that's kind of like lower performance, buying something from Dell or Lenovo is actually not expensive compared to having to build your own. If you want something that is reliable and you have control over the components, then you want to build your own computer. Now, when you build your own computer, you have to kind of put all the pieces together, right? So now you have to understand what those pieces are and how do you make sure that those pieces can all talk to each other, okay? So what do you think is the first thing that you need to consider when you are putting a computer together? Go ahead. Motherboard. Well, there's a little bit of stuff before you even consider the motherboard. Go ahead.
The specs.
The specs. All right, let's go with the specs. That sounds good. Okay. So when you put a computer together, I'm just writing this document here. As I'm, it's kind of using it as a whiteboard. Okay. So steps to assemble your own. Oops.
Are you going to post this? Are you going to post this?
Well, this is going to be recorded for sure. So if I want to You mean to save this file?
You know what I mean? So like when we're on the,
Make it available, make the document available?
Yeah.
You know what, last time we talked about this already, I kept forgetting about that. So what I'll do is I'll use Google Document, and then later on I can make the document itself available to everyone,
Yeah.
right? So this is reinforcement. What is this? We covered this topic already. Cloud application. Yep, exactly. So now what I'm going to do is to create a document. So just create a document. This looks just like a spreadsheet here. And what I'll do is I'm going to tear this tab away, to become its own browser. So this way I can use Alt tab to switch between the main browser and the document quickly. Okay, so we'll go ahead and let's see. Does it have a zoom feature? Nope. But I can certainly increase the font size. Okay. Steps to put your own PC together. And then we'll start to use the heading style, which is really helpful because it helps to organize the structure of this document. Okay, specs. Okay, what kind of specs are we talking about? When you want a new PC, why do you think you want a new PC? Other than the fact that your other one is stolen, broken, exploded, or something.
What you're going to use it for, whether you're going to use it for gaming or surfing. Or
Exactly. So what are you going to use it for? So that will drive the specification, won't it? Okay. So what are you going to use it for? So possible answers, or some of the more common type of answers, would be gaming.
What size you need?
Hmm?
What size you need?
What size? You mean the physical size?
Yeah, yeah.
Okay. Well, the physical size is is an outcome of the application. In other words, if you want it to be your desktop computer, the size is not that important. On the other hand, if you want to be able to carry it around with you, then the size becomes important.
Like for business.
For business, well, if you have a small home office, the size becomes important. But if you have a relatively large desk, and you have a lot of space, then the size is not important. So I usually would not put size, as what you're going to use the computer for. So gaming is one, office use is another one, general, family use can be considered one. Any other ones? Yep.
Video rendering.
Video rendering. Okay, very good. Video or 3D/3D rendering. Anything else? Does anyone do massive transcoding?
That's what I was about to say.
Okay. Transcoding video. Yep.
Music recording. Music recording.
For recording what?
Studio.
Okay, recording, studio recording. Okay, so studio recording. Yep. Graphics design. Okay. All right. So these are all kind of specific things that people use a PC for. Now you don't always have to pick one. There are places where you can use it for multiple things. Like I can use it for gaming and transcoding and 3D rendering at the same time, because those things actually drive the same specifications in the end. Well, you guys are missing one that is kind of useful, but I think most people don't use it for this purpose. Set-top box. To use your PC as a DVR.
Like a HTPC?
Yeah, like a HT PC. Yep. Home
HD what? HDPC?
HTPC.
Home theater PC.
Home theater. That's it.
Oh, HT.
Yeah, HT TV. Home theater TV, because that would drive certain specifications that may be missing from the other applications. Okay, so that's good. HTPC home theater. See? Well, since we are on this topic, the whole concept of having a home theater, like one big screen TV at home for everybody to watch TV, is slowly disappearing. because just in my own household, my kids would have their own videos to watch. They like to watch how other people play Minecraft, which I have no interest in. My wife and I like to watch certain types of movie, and sometimes I like to watch certain types of anime that my wife has no interest in. So being able to watch having at least one computer per person means that we can all watch whatever we want without having to have one centralized TV at all. How many people still have one centralized TV and everybody in your household will still watch the same program all the time? Yeah, it's not happening anymore. Yep. So I think that's really kind of an interesting thing, because it has to do with computers being so inexpensive. Because before, I still remember in 1982 or so, the Byte magazine, which has long since bit the dust. The Byte magazine had these PCs that are kind of like amateurish, and they were about $2,000. And this is back in 1982. Okay, $2,000 in 1982 is a lot of money. Was a lot of money. But today you can buy a PC for what? You can get a tablet that you can use to watch TV, YouTube and stuff like that, for how much? 200, maybe less than that. Okay. 200, $300. $300 will get you a really nice one. If you don't want to spend as much money, and only want an 8-inch screen or something like that, $150 to $200 will get you something. So that means it is completely feasible that every person in your household has a portable device for watching, TV, video, and whatever that is streaming. How many people still watch broadcast TV on a daily basis? I cannot remember the last time I watched broadcast TV. I really cannot. Okay, so that really is telling you something about how we get our entertainment, and also how our PCs are being used, because they are replacing the television, they're replacing the radio. When was the last time you actually used a radio to listen to music?
Today.
Oh, really? I use online radio in the car. Okay, yes, I can kind of understand in the car. Yes, go ahead.
Are they making the computers inexpensive like this because that's how it's going to be? Because that's how it's going to be?
Yes,
So
it's going to
everybody-
continue that trend. Computers will continue to become less and less expensive.
For that reason, because they
It's a technology thing.
right. So I mean, that's eventually you're going to have to get a PC because all the other stuff's going to be obsolete.
Oh, eventually your PC will be $50, $40, $30.
Well, think about how cable is run right now. I mean, we're not living off antennas anymore. All those TVs are crap.
Broadcast TV is becoming, really, just advertisement, right? I mean, for the most part. Yep.
I haven't looked at TVs recently, but do you think AirPlay, like enabling AirPlay with TVs and computers on these computers, will catch on?
What is AirPlay?
It's where you stream your computer's screen onto a bigger screen.
That will catch on because it is still more pleasant to look at a bigger screen, especially when you want to share the movie with other people. Yep, go ahead.
There's new technology when you go to some store, Sam's store, to getting televisions. Like a projector projects it. And you can call it up and it connects and it'll project what you want. That's pretty nice.
Mm-hmm.
Do you know what I mean? Kind of like these projectors. It's really a small little unit, and it's portable. It's easy to move around.
They've got phones that have projectors that you
Yeah,
can
they got these
attach
Right.
to your phone
inflatable
with a
screens that you
tiny
can blow up.
projector.
I only have one gripe about your projectors. It has to do with the contrast. Unless you're in a really dark room, the picture usually get washed out a little bit because of the background light. Even with a nice projector like this, if I turn on the last bank of lights, you will see the screen is starting to wash out. Even now it's washing out, right? So I think that's one big reason why I really do not like the projector technology, even though it's getting less and less expensive. Just the other day, I was browsing through wood.com. I go there on a daily basis. Wood.com. You guys don't know anything about wood? Wood. Okay. Let me go there and show you what is wood. Wood.com. W-O-O-T. Wood. So they sell they have a different daily deal on certain things. So certain days, they will have projectors. Another day they will have HDTV. Another day they have, it's just random stuff, okay? And they get these, sometimes it's a refurb, sometimes it's because other stores cannot sell it, and so on and so forth. But just the other day, I was going through this. They were selling a 1080p. Now, this is native resolution at 1920 by 1080 pixels. This is a projector for $500.
That's pretty good.
That is really good. I did not buy one because I just do not like the projection technology, because you need a relatively dark room to use it, and it's also kind of power hungry. It takes more than 200 watts, but it's intended to project to 8 feet or more. So I guess it's not too bad when it comes to the picture size versus the power consumption. But they have all kinds of stuff. If you want to look at technology stuff, you just have to go to the tech portion. Well, these are just cases. These are PCs. They just have all kinds of stuff, for kind of inexpensive prices. But it's a good place to check to really get an understanding of how inexpensive technology has become. So I think a $50 PC, not a PC, but a $50 handheld computer for personal use is in our future. Okay, I would give it another 5 years, 10 years at the most. Then you will have your personal computer, personal handheld device that you can buy for $50, $100 at the most. At the most. Okay. All right. So getting back to putting your PC together. So we'll switch back to the document. All right, so once you know what you're going to use the PC for, then you have all the other factors, all the actual specifications to really consider. Okay. So actual technical specifications. So we'll go through the purposes that you will be using a PC for, and then we'll determine what type of technical specification is relevant to your application. So this one is the application. What are you using your PC for? Okay, for gaming, what would be some of the specifications that you think will be important? Yep, go ahead.
High-end video card.
Video card, okay, so high-end. Okay, how about we just say video card performance? Okay.
Processor. Graphics.
Okay. Go ahead.
Processor, most important thing.
Okay, processor performance. Anything else?
Memory.
RAM.
Sorry?
Memory.
Memory, okay.
RAM.
RAM. Okay. RAM actually stands for random access memory. Yep, go ahead.
Power source.
Power source, okay. So that is driven in the end. That's actually driven by the other components. So I'm not going to put it here, as the first line of technical specification, because it's not directly driven by the application. It's driven by the components that is driven by the application. But it is an important factor. We will definitely include it. Yep.
Hard drive storage.
Okay. Is that what?
In case of a good cooling system.
Cooling system, okay. But that's also driven by the components inside the box, so it's not directly driven by the application itself. So I'm still looking for things that are directly driven by the application. So hard drive space is definitely one. Okay, mass store capacity. Okay. Yep.
The audio card. The audio card.
The audio card, okay. Audio capability. Capability. There we go.
motherboard?
Motherboard is driven by the other factors. So we'll consider all of those as quote unquote secondary specifications because these are the primary ones. They are driven directly by the application. But that's a good one. You know, we'll include it, you know, when it's time to do it. Yep.
You have to consider how much the motherboard can handle.
How much the motherboard can handle.
How many PCI slots it has, how many
Okay,
slots
well,
it has.
that's something that we can consider here. Video and audio connectivity. How's that? Because what we're talking about here with connectivity is, are we still talking about old school, you know, VGA port? Are we talking about DVI ports? Are we talking about HDMI ports? Or what? How many HDMI ports? How many of those ports can be driven at the same time? Yep.
I'd say DVI is more important than HDMI.
Okay, well, for certain
high-end
people,
gaming.
for high-end stuff, but it also depends on your TV or the video devices that you plan to connect it to. Okay, so that's one of the considerations. Yep.
DVR?
DVR.
Your CD or DVD?
Okay, if you want to turn your computer into a DVR, you need a tuner card, right? So you might need a tuner card. Tuner availability. There we go. Yep.
Disk drive.
Disk drive, you know, we covered that in mass store capacity. Now you might want to add something to
DVD or
capacity.
Blu-ray drive.
Oh, very good. Optical drives. Okay, optical drive compatibility. Compatibility. There we go. Yep.
OS?
Operating system. Well, that's
It's kind of important.
That's important, okay. Yes. Application programs, okay? Application programs, because that will drive, you know, which operating system you want to install. Yep. Anything else? Yep.
You need a lot of USB ports.
Number of USB ports or connectivity to other devices. Okay. Connectivity to other devices. Okay. Anything else? We're missing one thing about HTPC that is important to HTPC, but not really so much to other computers. Is it loud? Right? Now, some gaming PC can sound so loud by itself, it's like a helicopter taking off. You don't want that in your living room when you're watching a relatively quiet and, you know, silent movie, right? So, you know, the loudness or quietness of the computer can be important depending on its application.
Don't we need the case to store everything?
Yeah, the case is, but we use these factors to drive the decision of which case we pick, what component we pick, you know, which fan, you know, do we pick, how many fans do we pick, what is the size of the fan? Do you pick one really big one that's turned slowly, or do you want to have a whole bunch of smaller ones that, you know, like scream at a high, you know, pitch? Yep.
Wireless or wired connectivity, like Wi-Fi.
Network connectivity,
Yeah.
okay. So network connectivity, all right. Okay, so let's go ahead and see if we can associate, you know, measuring units to these things. Yep, go ahead.
What about CPU cooler?
That's driven by the processor you're choosing, as well as, you know, how quiet you want your PC. If you want your PC to be really, really quiet, you cannot pick a processor that generates a lot of heat, or, you know, you can dunk it into a fish tank filled with oil.
How about the camera? You know,
Camera?
internal camera?
Yeah, that's kind of that's connectivity. Yep. Because the camera is not built into the PC itself, or for the most part, it's not, unless you're specifying a laptop computer. Then you can have, you know, the cameras built into the computer itself. Okay, so let's try to associate measuring units. How do you measure video card performance other than how much you spend on it? Yep.
How many cores?
Okay.
And the clock of each core.
Okay, so we can say number of cores, clock speed, but in the end, what are you actually measuring?
Also video RAM.
Okay, but what are you actually measuring? What is the, how do you measure the throughput of a video card?
It's how many polygons it can render per second.
Exactly. Okay, so this is what you need to do, is to measure polygons rendered per second. That really is the bottom line. Yep. Okay, go ahead. There was another hand. Go ahead.
I was gonna say, if you're like picture editing,
Mm-hmm.
the number of polygons rendered isn't as important as like how many you can have total.
Okay. So how do you specify that?
Video RAM.
Hmm?
That would be video RAM.
Video RAM. Okay. So the amount of video RAM. Okay. Very good. Processor performance. How do we measure? This is a touchy one. Yep.
I'm sorry, what was a polygon?
A polygon is like a triangle is a polygon, a square is a polygon, a trapezoid is a polygon. So basically anything that has a fixed number of vertices, points, connected by straight lines is a polygon. In the case of a polygon rendering, we're talking about the polygon rendered in the 3D space, based on lighting conditions and whatnot. Okay, yep, go ahead.
I was gonna say for the processor performance.
Yep.
It would depend on how many floating point operations per second and
Mhm.
integer point operations per second.
But even those are not truly useful because Intel and AMD they understand the art of tweaking specs, so they can bump up the claimed number of MIPS, million instructions per second, and flops, floating point operations per second. So they can bump up those numbers without actually realistically making the computer faster. So for processor performance, the best way to really evaluate it is to use existing benchmark programs. Okay, benchmark numbers. So you can go to tomhardware.com and many other websites where they will actually post actual realistic numbers on these things. Okay, so benchmark numbers. How do you measure RAM? Okay, there's two aspects of RAM that you have to consider. The first portion is the capacity. Okay, how much? So how do you measure the amount of RAM you have installed in your system? The number of bytes, exactly, the number of bytes. Now, we don't really measure in number of bytes because the number is huge, right? So the most common units for measuring the capacity of RAM is gigabytes, okay? So these days, we all use gigabytes as the measuring unit, which is 1 billion bytes, okay? Approximately 1 billion. Yep.
What's a good amount of RAM, like 1 gigabyte?
It depends on what you're doing. 1 gig of RAM is usually considered very tiny these days. You load up Windows 7 and it takes up 1 gig of RAM. 1 gig of RAM. Okay, so when you try to load up even Internet Explorer, you will try to swap things around and your computer will become exceedingly slow. So just to boot up your computer in Windows 7 and go online to do simple stuff, you need 2 gigs of RAM, realistically speaking.
This would be on the desktop?
Hmm?
Desktop, like on the
Desktop or laptop. On a tablet, it's different.
Yeah, okay. What
Yeah.
do you get for tablet?
Sorry?
How many RAM gigabytes do you get for tablet?
For tablets, you still need about half a gig at least, depending on what you're doing. Yep.
That seems like 4 gigs is like the average, like everyone just goes with that.
4 gig is the de facto standard of a kind of general purpose PC. Something that does not have any specific requirement. You just say, okay, I just want to install this PC as a home computer. That's 4 gigs already for most people. The jump from 2 gig to 4 gig, the cost increase is not much. But from 4 to 8 is a little bit. From 8 to 16 is a lot more. But I know a lot of people who are gaming, they install 16 gigs of RAM like from the get-go. I can see some of the gamers going like, yeah, exactly.
The computer is pretty old, 2005. I bought a external, Tetra, hard drive. And what I did is just transfer as much as possible from my operating system C and drive to my external. And still, this is slow. I empty like maybe no more, like 120 gigabytes available on my operating system in order to use it, and it still is slow.
You're talking about hard drive space and not memory space. Yeah, hard drive space is a different thing. Okay, but let's finish up, RAM first. How do we measure the performance of RAM? Not the amount, but the performance. Okay, the first one is the DDR technology, right? We talk about DDR3, DDR5, and so on. Okay, so that's the technology. And then the other part has to do with the clock speed. When you specify DDR3, they are available for 1600 megahertz. Is that kind of the standard right now? 1600 megahertz for RAM. Okay, because they do make slower ones. At 1333 megahertz, or even slower. So the clock speed definitely matters. Yep, go ahead. Latency. Okay. Now latency is something, or specifically the CAS latency, right? That's something that is not usually published, depending on the website. Now, Newegg is pretty good with documenting the all the latencies because it's catering to a more technical clientele. But when you go to Fry's, a lot of times when you look at the packaging, it doesn't really say that much about the latencies. But latency is definitely one of those things where the smaller the number, the better. Okay, because it's basically means it doesn't have to wait as much to get to the next location. Okay, mass store. Okay, let's separate mass store into two portions here. The first part is capacity. How do you measure the capacity of your mass store or your hard drive? Either gigabytes or terabytes now. Okay, so it's measured in terabytes, which is a trillion bytes. Okay, 1 terabyte is 1 trillion bytes, which is an insanely large amount of bytes, and for some reason, some people can still fill it up. I have a 2 terabyte drive and it's all filled up. No, I don't. I can barely fill up about 400 gigabytes at this point, and I could not think of anything else that I need to store onto those drives. Sorry? Sorry?
Because I bought a 2 terabyte hard drive and I'm already past 1.5.
That's a lot of stuff on that drive, especially when we are already talking about using Google Drive and storing other things online. So it takes a lot of stuff to fill up 1 terabyte.
They're really nice. Terabyte drives are really nice for people who take a lot of high resolution pictures, like you're down like your 14 megapixel cameras.
Mm-hmm.
And those take up a lot.
And you store in RAW format.
Right.
So for professional photographers, you definitely need a hard drive that is rated at a high capacity. Yep.
The same thing with the videos and audio work, where you have your whole entire library
Mm-hmm.
AC.
Yep.
Then you're going to be looking at a lot of space.
So 2 things that we mentioned here can use the extra storage space. A DVR, set-top box is a DVR, and also an HTPC. They can both use a relatively large hard drive, because if you're recording programs, over the air or over cable, you can use up a lot of hard drive space.
I use my terabytes, 13,500 pictures and 350 videos, and another things that I program for videos,
Mm-hmm.
shows, slideshows, and almost use that for me. I think a picture takes a lot of space.
Okay. Now, even if you have a 3 terabyte hard drive, if the performance of the drive is terrible, then you will still have a very uncomfortable time doing your photo editing, video editing, and stuff like that. Because whatever you do, you have to wait 4 seconds for it to become effective, right? Okay. So how do you measure the performance of a mass store device? There are several factors. Okay, it's not just one. Go ahead.
Hard drive, like the spin speed and cache.
Okay, the spin speed is usually measured in RPM, or revolutions per minute. The standard one is for desktop computer is 7,200 RPM, but the high performance ones are 10,000 RPM. Yep.
Isn't that eliminated with solid state drives though?
Correct. That is no longer a factor with solid state drive, but solid state drives can only go up to a certain capacity. Right, the capacity is the issue, because you can have a solid state drive where you have no RPM, no latency due to rotation, but at the same time your capacity will be limited to less than 1 terabyte unless you're willing to spend a lot of money.
Why is it that the capacity is a problem still?
It's just silicon is not ready yet. It just doesn't have the same density as storing information on a magnetic medium on the hard drives. It's just not catching up yet. Okay, go ahead.
Read and write speed.
Read and write speed. All right. So let's see. Well, besides RPM, there's another physical thing we have to consider. Seek time. Okay, seek time is usually measured in milliseconds, and that has stayed at about 7.9 to 8 milliseconds for eternity. I have no reason why they cannot reduce it any further. With newer hard drives, they are still about 8 milliseconds. What you're talking about is the bus speed. Okay, so you're talking about the SATA, S-A-T-A speed, because SATA, which stands for serial ATA, comes in different versions. The earliest version is only 1.5 gigabits per second. Then we have 3 gigabits per second. I think the current standard is what, 6 gigabits per second? So that's definitely one of the factors. Now, just because your drive can talk at 6 gigabits per second does not mean that it can sustain 6 gigabits per second all the time. Okay, so that's why that alone is not a deciding factor at all, because practically speaking, most of the time your hard drives would be limited by the RPM and the seek time. The physical delay of a hard drive are typically the most important limiting factors. One thing you can also consider is the amount of cache on the drive itself. I have no idea what is the current standard, 16 megabytes or whatever. So the more cache you have on the drive, it means you don't have to seek as much, and you have less rotational delay. But there's one more thing about mass store device that you have to consider, and I'm hoping that most people have not encountered this problem yet. Okay, let's say you have a 3 terabyte hard drive kind of filled it up, okay? It has extremely good performance, okay? And you put all kinds of stuff on it, and then one day it just crashed. What are you gonna do?
Cry.
Yes.
Backup.
Okay, so we are talking about, well, a backup is a good idea, but you still want to avoid having to go to your backup if it is possible, right? The reliability, right? The reliability of a hard drive is also important. Okay, so how do we measure reliability of hard drives? What is the typical unit for that sort of thing? MTBF, mean time between failure. Now, mean time between failure, which is basically, according to statistics, okay, according to the manufacturer, this is the amount of time between two, hard drive, actual hardware failure, and the longer the time, the better. But that alone, does not it doesn't represent the reality. A lot of manufacturers will publish a really big number for this. The bigger the number, the better. But depending on the manufacturer and depending on the model of the drive, you can still see realistic, real life numbers that are different from the rated MTBF. Okay. Yep. Go ahead. What is the standard number?
Yeah.
I have no idea these days, because I don't really pay attention to MTBF. Instead, I read about what other people have to say about a particular model of a drive. If you go to newegg.com, you can see a lot of comments. You basically, okay, let's say you picked out the 3 drives that have the capacity and the performance that you want. So what you want to do is to look at the feedback from people who own the drive, and you can compare and say, okay, well, it seems like a lot of people who own this drive complain that the drive will start to die within 2 years, whereas with the other drives, it seems to be a lot more stable, more reliable. So you have to rely on feedback from other people when it comes to realistic information about the drive, and not just to rely on the numbers.
What website was that?
Newegg. Newegg is only one of them. I have no affiliation with newegg.com at all. I just use it a lot because it has a lot of information for this kind of purpose. Okay. Now there's one more thing about mass store. If you want to improve the reliability of your drive, and say that even if a drive is dead, I can still use the computer. Okay, so what you'll be looking at in that case is called what we call RAID. Okay, RAID stands for redundant array of inexpensive drives. Okay, so what this means is you can have multiple drives, like 3, 5, or more, working together. And the redundancy is done so that if you have 4 drives, you can afford to have one completely failing, and then the other one can still quote unquote limp along until you have time to replace the 4th one. Then you have the redundancy back. So as long as you don't have 2 drives that are failing at the same time, then your content will still be okay. All right? Now that's a really good thing, because if you think about it, most drives would survive at least a year or more before it starts to fail. So as long as your drives you do not have 2 drives failing at the same time before you have a chance to replace one, you'll still be okay. Yep.
Unless you're using the striking format of RAID, where you're just using all your drives all the time and spread the information out.
With RAID 5, which does do striping, it also offers redundancy. So it has striping and redundancy at the same time. But the redundancy is only 1 drive. In other words, you can only afford to have 1 down at a time before you start to lose content. Now you can also have what we call a hot spare. So the minimum to set it up is to have 4 drives, 3 for the RAID, and 1 as a hot spare. So if one of the 3 fails, you will still be able to limp along. But since you have a hot spare, it immediately starts to replicate using the hot spare. So within the replication time, if you have another drive fail, yes, you'll be dead. But once you have the 3rd drive replicated to the hot spare, then you can have another drive fail and not lose content. So you have a much smaller window of of losing your content when you have a hot spare, because you don't have to go to the store to buy another drive to plug it in, because it's already there.
That's in RAID 5?
Yeah, with RAID 5 you can do it. Yep. So we don't have any more time, so I'm going to save this and give you guys the link to the document up to this point. Yep. Mr. Saunders. Okay, go ahead. Today is the 4th. How come someone's putting on the 9th?
So.
Okay. Someone is future tripping.
I'm good.
Someone is future tripping.
Right there. Pardon.
Are we going to have other homework assignments besides the upcoming 2 ones that are coming up?
Okay. There'll be more.
Oh, thank you. I was looking for grade, and I was seeing class and it's right now.
Okay.
So if I get a 60,
yeah, right now we only have maybe about 30% of the entire grade determined. So you still have at least 70% to make up. Yeah.
Okay, because it was minor stuff. I talked to you last time about putting in the wrong Gmail account. So one of the homework assignments that I put in didn't get counted.
Yeah.
So.
Hopefully more homework assignments will kind of wash it away.
And are they kind of easier than the checkpoint homeworks, or are they around the same? Because computer technology stuff is not my forte. So
okay. Yeah, we'll have some programming stuff, like Scratch. And then we'll have a presentation at the end of the class. So that one is really just based on how well you can present the material. It doesn't have to be completely technical.
Oh, okay. And then we just have one final exam?
And then we have one final exam, and we have a second exam as well.
Okay.
So we have a second exam in about 2 weeks or so. We'll have a second exam, and then the final exam and the presentation. So we still have about 70% of the grade to be determined.
Okay, so there's still room for me to at least get even under B if I were to work.
Oh yeah,
okay,
yeah. A B is definitely within reach.
Okay, sounds good. Thank you.
guys doing?
Good.
We have about 4 weeks, I think.
I'm ready.
You're ready.
Let's get it done. I'm taking 19 units this semester. I'm just trying to get through and stuff.
I literally needed like 2 more units last semester to transfer, and there was only like 3 schools accepting spring transfers, so I just took more classes.
Yeah. It's not expensive taking classes here.
I can find today too, so I don't even have to.
Yeah. Get it done here, because I pay a lot of pocket for here, because when I go to Sac State, I'm really under it financially at $5,000 a semester, whatever it is now.
Ooh.
Yeah.
I want to transfer to Davis, but I won't find out till the end of the month.
See, and Davis is even more.
Yeah. It's even more.
Yeah.
Exactly.
But if not, I just started in Cal State Fullerton, so I'll probably just go there.
It makes you wonder. I mean, UC Davis is, or all UCs are pretty close to private schools already.
Yeah.
Because University of California, yeah. Definitely.
Yeah.
Well, a lot of them, because each of them have such different like standards. Like Berkeley, they're like a semester school compared to quarter school. Like all the other schools, it just seems like a lot
Berkeley
of
is
things
quarter.
different.
Oh,
Berkeley's
excuse me, you're right.
semester.
Berkeley is a semester, and
It just seems like
everybody else is
they're so much
semester.
more independent on like what they do compared to like state schools. I feel like.
But they don't even call themselves UC Berkeley. It's Cal.
Yeah, exactly.
Yeah.
That's
Yeah. Or it's like Cal Poly.
Yeah, well, Cal Poly is a state school.
Right.
Yeah.
Oh, okay, yeah.
Cal Poly is CSU within the CSU system.
Doesn't seem like it should be, but.
Right, exactly. I mean, even.
I applied there and they sent me a letter back saying that they only, out of 50,000 people, they only accepted like 4,000. And I was like, dang. And like